In this video, we're going to look at a basic introduction to three-figure bearings. I'm going to start off by drawing a port in the middle of the paper. So this is a shipping port. Our port is going to be just here. What we're going to do is look at the bearing of a number of ships from the port. Whenever I'm doing a problem like this, I like to draw a horizontal line and a vertical line. The vertical line will be the north line. So if I go ahead and draw a vertical line through here, this is my north line. I measure it up and I'm going to write now that this is north. I'm going to find now the bearing of a ship from this port. I'm going to put it just here and I'm going to call this S1. So this is ship number 1. When we're measuring bearings, we're simply measuring angles. We do though need to remember 3 specific rules. The 3 rules are as follows. When we're dealing with bearings, we measure from north. So we measure from north, just jotting this in. So measure from north. We must measure clockwise, that is the second one. So we measure clockwise. So measure clockwise. And then finally, as it's 3-figure bearings, our value must have 3 figures. So we need 3 figures. That means that all bearings less than 100 degree will simply have a 0 in front of them. The way I like to do this now is to draw a line from the port to ship number 1. So we're looking at the bearing of ship number 1 from the port. If we were asked for the bearing of the port from ship number 1, that is a different calculation. We're going to look at that later in the video. I pick up my protractor. And you might have a protractor that looks like that or one that looks like that. It really doesn't matter. And all we're going to do is move this into place. So I can see now this is in place. I read from the top 0, 10, 20, 30, 40 and so on and so forth. And we're looking now to find the bearing of S1 from P. I can see reading up that is about 25 degrees. The further I extend that line, the better it will be. But hopefully you can see 0, 10, 20, 25. So we can say now that the bearing of the ship number 1 from the port is going to be approximately 0 to 5. So we can write this in 0 to 5. So the angle is 25 degrees, the bearing is 0 to 5 degrees. Let's go ahead and put over here now ship number 2. So let's put S2. So I'm going to have S2 and I'll put S2 just here. So all I'm going to do at this stage now is draw another line from the port to S number 2 and we're going to look at the bearing of ship 2 from the port. So if I wanted to do that, I'm going to put this into place. I can see now that I need to read round the top of the protractor, so make sure this is nice and in line, and I can see that that is going to be approximately, give or take, 75 degrees as an angle, 0 to 10, 20, 30, 40 round the top. Therefore, as a bearing, we can write this as 0.75 degrees. So the ship 2 is on a bearing of 0.75 from the port. Let's draw another one. Let's have ship number 3, and we'll put ship number 3 down here. So ship number 3 is going to be just here. So this is S3. If we now draw the line from the port, we're looking at the bearing of ship number 3 from the port. This time we've gone now over 90 degrees and this looks to be well over 100 degrees. Therefore, we will have our 3 figures already done for us. So if we put this back into place, we can see now that that is about, and I'm getting these fairly accurate to multiples of 5, it looks to be, give or take, and we can just stretch it if we want it, make that a little bigger, really doesn't matter. Do make sure you're fairly accurate with this. That looks to be about 114 degrees. Therefore, the bearing now is going to be 114 degrees. So we'd have at this point now the bearing of 090. So if we were right now due east, we would have 090. We're now just in the southeast region. So let's just move that out of the way. So hopefully that makes sense, that now east, and I'll just put it on here. So we've got east, so we'll put east just there, that is east. If we're on a bearing now of 180 degrees, we are heading south. If we're on a bearing of 270 degrees, we're heading west. And of course, naught, we've got 0 or 360 degrees. Okay, let's go ahead and do another one. Let's say we've got one, and we'll turn this over. Let's go down here. I'm going to have some ship, and the ship is going to be just here, and we will call this S4. So S4 is going to be here. This is beyond 180 degrees. So all I'm going to do is draw a line up. If you have now one of the full circles, what you can do is simply go ahead and work it out from there. So if I had that, I could now read that that was going to be round here. So let's just go ahead and spin this into place. So I'm just going to put this up, put the protractor now, so we're starting on naught. So if I do that, let's roll this around. We want to find naught. So taking now naught to the top, and you can do it either way round, we will start just there. So that looks pretty good. Let me just spin that to naught. That hopefully we can get that bang on. That looks pretty good. Just move that into place now. We can go ahead and read this. So let's put this in place. There we go. That's pretty good. So if I look now, I'm reading around the top, and we can see that now the bearing is approximately 220 degrees. So that's what we can write. It's 220 degrees. So what happens if you don't have one of these and you can't read round here? There are a couple of different approaches. What we could do is simply now take this back to being a single one, and we'll just move this out of the way. Let's get this out of the way. And if I had a single one, I'm going to have both a single and a double. What we could do now is the following. If I spin this into place, what we could do now is measure round the other way. This is entirely up to you. So if you wanted, you could now measure around this way and subtract this value from 360 degrees. So I can see if I wanted now, I can measure around the inside 10, 20, 30, 40, 50, 60, 70 and so on, round to 140 degrees and subtract that now from the 360. Alternatively, what we could do is place now the 0 here, and if I just move that slightly, hopefully you can see this is 0. We measure round. This is a 40-degree angle here, so we would add that now to the 180. So hopefully you can see you've either got the full circle or you've got the semicircle. Either way round, if we have these bearings that are over the 180 degree mark, you can either work this way on from 180 or this way back from 360 degrees. So if we look at this, another one, let's go ahead and put another ship on. Let's put one just here, and we will say that this is S5. So ship number 5 is there. I would simply draw a line connecting the two, and we're going to look at the bearing of ship number 5 from the port. So if I did that, I could go ahead and put this into place, and I have the choice. I can read round the inside, so let's go ahead and do that. If I read round the inside now, that looks to be about 22, 23, we'll say 23. I could subtract that from 360, or I could measure around the bottom and add that on to 180. So let's just subtract. Let's say that this angle was 20. We'll say that's 23. So this right here is going to be, now I'm just jotting this on, this is going to be 360 minus 23. So that's going to give us now 300, and what's that? 337 degrees. That is the bearing. Okay, so that's nice and straightforward. That's all from the same port. So we're looking at the bearing of those. Let's say we wanted now the bearing of ship number 1 from ship number 5. So what I do at this stage is simply go ahead and draw my lines. So what I'm going to do, I want the bearing of ship 1 from ship 5. As soon as I hear the word from, that is where my north line is going. So I'm going to put my north line up, and that is going to be at ship 5. So if I just scrub out this part right here, let's go ahead and just clear this. So we'll have that. We've got now this north line. I'm then going to draw a line connecting ship number 5 with ship number 1. What we're looking for is the bearing of ship 1 from ship 5, and the angle that we're looking for now is this one right here. So my north line, I know that I measure from north, I measure clockwise, and I give it 3 figures. So with now the protractor, we can pick up the protractor, and it doesn't matter whichever one you use. Let's go ahead and do that. We can put that on here, and we're measuring, of course, on here. Hopefully you can see. Let's see if we can just make it a little smaller. There we go. So we're measuring now round this way, and that's approximately, let's just have a look at that, give or take 110 degrees. So the bearing of ship 1 from ship 5 is about 110 degrees. In a later part of the video, we're going to look at, as a result, finding the bearing of ship 5 from ship 1 using angle facts. Okay, let's go ahead and do some questions. On here, we're told A and B are 2 towns as shown below. So we've got A here and B here. In part A, we're asked to measure the bearing of B from A. And then in the second part, measure the bearing of A from B. As soon as I see the word here, from, that is where my north line is going. So when you hear the word from, put your north line there. So let's go ahead and put a north line on. Our north line is going up here, and it's like so. I'm now going to draw a line connecting the two. So if we draw that line connecting the two from A to B, and it's going to look something like so. So there's the north line, and if you want, you can measure it up, or say measure it up, just put it on and scale it down. It's entirely up to you. I don't think we would need to do any measuring. Let's go ahead and just put this on. So what we can say is this is the north line. So for the first part of the question, what we're going to do is simply measure this angle right here. So with the protractor, I'm going to pick up the protractor, lifting it in, and we've got now 0. So putting it right on that point just there, that looks pretty good, and that looks to be 58 degrees. So that is the angle, so the bearing is going to be now 058 degrees. I've measured from north, I've measured clockwise, and I've given it 3 figures. So that now is part A. Let's go ahead and find now the bearing of A from B. This is the one that often causes confusion. So I've seen the word from B. So as soon as I see the word from B, I'm going to put now the north line. So I've got my north line. What we're looking for now is to measure clockwise. We're measuring from north, and we need to give this 3 figures. The bearing is going to be this angle around the outside. So we've got a couple of choices. If we've got now the double protractor, then what we can do is simply go ahead and measure right the way around. Alternatively, with the single, we can measure this angle and subtract it away from 360. Or if you like, you can extend that north line downwards. If I extended it, and measure the angle on from 180 degrees. What we're going to see very shortly is that there is a much more effective way of doing this. So if I just now spin this round, let's turn this round, we will have this scenario. So what I'm going to do is now just put this in place. That will go just there, and I'm going to measure on. So hopefully now you're going to see a nice little result happen. If I put this on, what I've got here is about 58 degrees. I'm going to add that on, so let's go ahead and do that. That angle right there, measuring around the bottom, let's put this on. That is about 58 degrees, so it's going to be 180 degrees plus the 58 degrees, which is going to give me in total, what's that going to give me? 238 degrees. Now this is an interesting result, and hopefully you've already spotted now what we're going to do here. We have now an opportunity to use angle facts. If we look what we've just done, we've got now 2 north lines. These are parallel, so we can say now that this line is going to be parallel with this one. We know that this angle right here is 58 degrees. We can use the property of co-interior angles. Co-interior angles sum to give 180 degrees. So if we look at this one right here, this is going to be 122 degrees. So we were asked to measure. If we're not asked to measure and we're simply asked to find, then we can go ahead and use angle properties. So this bearing right here, we can say for the second part, A from B is simply going to be 360 degrees minus the 122, which of course is going to give us what we found of 238 degrees. So unless you're asked to measure them, do the first one and then go ahead and use some basic angle facts to say now co-interior angles. We know that these are what we call C angles, and we can go from there. If you think as well, what I could have done is use alternate angles or Z angles here and said, well, that one is 58 degrees. Just consider now, all I've done is said now that if these are parallel lines, this is a transversal, so we can go up from there and do that. So that's what we get. So that's what it looks like. So that one will be that one, and this, of course, we're just adding to the 180 degrees. So hopefully you can see the difference between measuring and finding and how you can find those bearings. Okay, let's do another question. We've got point D is 5 centimetres from point C. The bearing of D from C is 070 degrees. We need to calculate the bearing of C from D. So let's just go ahead and draw a quick sketch. What I'm going to do is put this on. Let's just put C here. So we'll have C, that's going to be C, and then we're going to put a north line up. So the bearing of D from C. So straight away I'm going to put my north line up. Then what we're going to have is this bearing, and we're going to have now a 5 centimetre line. So let's just go ahead and we'll put this in place. What we'll do is grab this. So we're now going to look at a bearing. Now the bearing is going to be 070 degrees, which is going to be somewhere just here. So let's put that on there, and we can put this just here. So 070 is there. I'm measuring from the top, so round the top. I now need to make this a 5 centimetre line. So hopefully with the ruler we can do this. I don't know how accurate this is going to be. Let's see if we can spin that round. Okay, let's tilt it. Remember, yours will be better than this. Right, let's go down the bottom. That's what we want. And then hopefully now we can just move that into place. Right, that looks to be, now let's just put that there. And we'll say that that's about right. Okay, it's not brilliant, but it gives you some idea. So that is going to be this point just here. And that will be 5 centimetres away. So we're going to just put it here. That's 5 centimetres. And I'm just going to move this out the way. So that now gives us the following. So let's put this on, and this is going to be the point, and this now is the point D. So that's point D. So let's go ahead and put D on. What we want to do now is find the bearing of C from D. So if I think what I've got a line connecting the two, so we'll draw this line connecting the two, and now I'm going to put a north line on at D. So what we're being asked to do is find now the bearing, and that is round the outside. So if we just put these two north lines on, we've got north just here, so that is north, and we want now the bearing of C from D. That is this angle right here around the outside. We measure from north, we measure clockwise, and we give it 3 figures. We already know that this angle right here, or the bearing, is 070. So that is a 70 degree angle. Therefore, this one right here, using co-interior angles, because these are parallel, this angle right here is going to be 110 degrees. So if we want this bearing, we have a choice. We can either subtract the 110 from the 360, or we can simply drop this line down and use alternate angles. Therefore, the bearing of C from D is going to give us now 250 degrees. So we can say 250 degrees. We don't need to measure it. It's either 360 degrees minus the 110, or we can say it's for 180 plus now the 70 degrees. So that's done. Okay, let's do the next bit. The point E is 7 centimetres from point D on a bearing of 135 degrees. We need to measure the bearing of C from E and measure the distance from E to C. So let's go ahead and do this. We've already got a north line at D. from point D. So we want a bearing of now 135 degrees. So if I look now, if I just scroll down, 135 degrees, measuring from north, measuring clockwise, we go round the outside. So I'm going to measure now, so for point E, we're going to be at 135 degrees, which is about there, give or take. So now we need to be 7 centimetres away. So let's do that. Let's see if we can move this out of the way. So we're going to get the ruler, and hopefully now we can put this in place. As you can see, it's quite fiddly with the ruler. I'm sure someone else would be better at this, but it should give us some idea. So let's see if we can do that, and it might take a bit of fiddling, but we should get there. So let's just spin that. Right, there we go. Let's do that. That goes there, and then if we move this around, right. So we want that. Looks pretty good. I'm going to leave it like that now, just so I don't do anything crazy. So what we're going to do now is put on here, this is going to be 7 centimetres away, and that is going to be that point just there. So just marking it off, we've marked that there, there we go, that is going to be E. So if we put that on there, that is going to be the point E, and we can connect this up. So if I go ahead and connect this up, down here, D to E, that's that, and that gives us this bearing right here. So we've gone ahead and done that. So let's do that. So let's put E here. So we've got E just here. We need to measure the bearing of C from E. So what I need here is a north line, and putting the north line up, we've got this scenario. You can, of course, use angle properties to solve this one. What we're being asked to do, though, is simply now measure it. So what we're looking for is this particular bearing. Now I'm going to put this on in a different colour. Let's go ahead and do that, and we will put that on like so. So what I'm after now is this angle around the outside. So we've got now the point E. I've got a north line. If we put this on, this is my north line, and that is going to be the bearing that we want. We want to come round the outside. So all I'm going to do is simply now measure this angle right here and subtract it from 360. As stated, it's entirely up to you on how you want to do this. I'm just going to flip this over. Let's grab this up. We'll put 0 just at the top, and then I'm going to measure round. So if I do that, putting it in place, we're going to have now our north line. That looks to be, now if I measure on the inside, that looks to be about 74 degrees. So all I'm going to do to work that out is subtract that. That might not be bang on, but it's pretty good. So what we're going to do is the following. We're going to do 360. So we'll do 360 minus the 74 degrees, and that's going to give me 286 degrees. So that now is the bearing of C from E. We could, of course, gone the other way round and added this angle right here. And if we were measuring now, remember we're measuring from 180 this time round the bottom. That looks to be 106 degrees. And of course, if we do 180 plus the 106, that will give us 286 degrees. So that is purely by measuring the bearing. So now we need to find the distance. So let's go ahead and just put this in place. This seems to be the hardest part of this. Let's see if we can get that parallel. That looks pretty good. And that, I'm getting quite lucky with my numbers. I'm going to say that that is going to be, just moving that in place. That's not brilliant, but it gives us some idea. That's going to be, and remember, you need to be a bit more accurate. I'm going to say that that's going to be 10 centimetres. So I'm just going to write on there from E to C is going to be 10 centimetres. I could get really quite picky, but I'll just say that that is going to be 10 centimetres. So there we go, that's what we end up with. In a later video we'll look at some more advanced techniques of solving these problems, but for now hopefully that's given you enough to move forward with. So let's go back to the 3 rules. We measure from north, we measure clockwise, and we give our answer 3 figures. Whenever we're told now the bearing of B from A, the north line goes at A. Of A from B, the north line goes at B, and we can either measure them or we might be asked to use angle facts to go and find particular question or answers to them.